Lesson 11.1, Similar Polygons. What are similar polygons? Well, let's start with the concept of similar figures. Similar figures, the definition of just similarity are two figures sharing the same shape, but not necessarily the same size. Now, this is what we use to come up with the definition of similar polygons, which are two polygons whose corresponding angles are congruent and whose corresponding sides are proportional. Let's say we were given these two polygons here, these two quadrilaterals, ABCD and EFGH, and we asked ourselves, are these polygons similar? And if so, why? Well, there's two criteria that we have to meet. First of all, according to our definition, the corresponding angles must all be congruent. In this case, angle A is congruent to angle E, B congruent to F, C congruent to G, and D congruent to H. So that criteria is met. But secondly, we also have to prove that the corresponding sides are proportional. Remember what this means. That means that if we were to look at the ratio between length AB to length EF, let's say 6 to 9, this ratio must be equal in value to the ratio of length, say, AD to the length EH, or 9 over 13.5. And the same with the ratio of length BC to FG, 14 over 21, and the ratio of CD to GH, 5 to 7.5. Now, mathematically, if you were to do the division with all these numbers in a calculator, all these ratios would be equal in value. Hence, quadrilateral ABCD is similar to quadrilateral EFGH. Now, to test for similarity, we need to check the two criteria that we had just discussed in the previous slide. We need to make sure that the corresponding angles are congruent and the corresponding sides are proportional. Now, in this case, all the angles are congruent, so we don't have to worry about the angles. But what about proportionality between the corresponding sides? Let's test it. So first of all, we have length DF and length AC, the ratio 20 to 8. Then length FE to length BC, 15 to 6. And length DE to length AB, 18 to 7. Again, let's do the division. 20 divided by 8 equals 2.5. 15 divided by 6 equals 2.5. 18 divided by 7 equals 2.57. Because these three ratios are not equal in value, we can conclude that triangle ABC is not similar to triangle DEF. Now, these values here that we got, the 2.5 and the 2.57, by the division that we just did, these are all called scale factors. Scale factors are the ratio of the length of a side in a polygon to the corresponding length of a similar polygon. In this case, since the scale factors are not equal, the triangles are not similar. Now, what if we were to actually look at the problem from the other point of view, doing it the other way? Let's say that the triangles are actually similar. And instead, we want to find the unknown side lengths, in this case, the length of x and the length of y. Now, to set this problem up, we need to begin by setting up our ratio. Let's be consistent here in how we set up our ratio. Let's say that we take a side from the triangle ABC and compare that to the length of a side from triangle DEF. As long as our ratios are consistent with one side length in the numerator and the other side length in the denominator, then our calculations will be good. Now, let's use proportions to find each unknown side length. We have one ratio there where we actually know the lengths of the corresponding sides, and that would be between length AB and length DE. Now, length AB is 4, length DE is 10, so let's use that ratio in setting up our proportion. Let's say we wanted to find length x. So then the ratio corresponding with this corresponding pair of sides would be 6 over x. So we set up that proportion. 4 over 10 equals 6 over x. Cross multiply and solve. X equals 15. We wanted to find length y. We still begin with the same ratio, 4 over 10, except now we'll use y in its corresponding side 12. So we set up the proportion 4 over 10 equals y over 12. Cross multiply and solve. So y has to equal 24/5. Thus concludes today's lesson.